We're going to take another look here at properties of logarithms today on this lesson. Again, this is lesson 12 from your Unbounded online textbook. Again, you should have your student version in front of you here that's blank, and we'll fill it in together as we go along. So, opening exercise here says to use the approximation log 2 is approximately 0.3010 to approximate the values of each of the following logarithmic expressions. So, for log of 20, that is, how can we rewrite that just so it's just log of 2? Remember, log of 20 is log of 10 times 2, right? And because we have multiplication here, we know that that can be changed to addition between two logarithms like so. Log of 10 we know is 1. We know that log of 2 is approximately that 0.3010, and so we get 1.3010 as our answer there. Okay, log of 0.2, well, that's log of 2 divided by 10. Okay, or we could say it's 1/10 times 2, which is the same thing as saying 10 to the negative 1 times 2. Which again, we can use this property where we have a product inside becomes addition outside between two logarithms. So it's be 10 to the negative 1 plus log of 2, which means log of 10 to the negative 1 is going to be just negative 1, right? What power of 10 gives you 10 to the negative 1? Negative 1 does, right? So that's why we get negative 1 there. Okay? And then log of 2, again, we said is approximately that 0.3010. And so we'll add these two things together here. And we get negative 0.699. Okay? Now, log of 2 to the 4th. Okay? In this case, it's log of 2 times 2 times 2 times 2, which then we have 4 things multiplied together here, so it'll be log of 2 plus log of 2 plus log of 2 plus log of 2. But you can see we're adding up 4 logs of 2, so we could really just write this as 4 times the log of 2. And you'll notice then that what we really did from here to here is that we merely brought this exponent of 4 out front, like so. Okay? And so this will be 4 times 0.3010. And I should put approximate there because now we're using that decimal approximation. Okay. 4 times 0.3010 is 1.204. Alright, so let's take a look at some of these here. So for exercises 1 through 6, explain why each statement below is a property of base 10 logarithms. Okay, so property 1 here is if you take log of 1, you'll get 0. Now this is actually a property that can be generalized to any logarithm. So a more general logarithm, you can say, is log base b of 1 will be 0. Okay, where b, again, is greater than 0, and b is not equal to 1. Okay, this is true in general. I guess even if b is equal to 1 there, it's going to be where that'll work okay too. I guess I can kind of drop that as well. Just b's got to be positive. Okay? I guess it's true for negative numbers too. So anyway, there we go. Okay? So for this, how can we prove it so? Well, so let's rewrite it in exponential form. Remember, this is really log base 10, so just use the exponential form. 10 to the 0 equals 1. Well, check that's true, right? 10 to the 0 is 1, so that means this is going to be true too. Okay, what about log base 10 of 10 equals 1? Well, same kind of argument here. Again, log of 10 is really log base 10 of 10, and we say that's equal to 1. So again, rewrite it in exponential form. 10 to the 1 equals 10, and yeah, that's true, so this is going to be true too. Remember, if we have a logarithm with base b of a, and it's equal to some number x, the equivalent exponential form here would be b to the x equals a, right? What power of b is a? The x power. So it's b to the x equals a would be the equivalent exponential form. All right. In the next video here, we'll get into these later properties.